Hello, everybody, and welcome to this session in the certificate programs in Python for algorithmic trading and computational finance. This is the introduction and overview session. My name is Yves. I'm founder and CEO of both Python Quants and the AI Machine, and also the program director of the two certificate programs. Many of you I know are doing the two of them together, which we then call the Platinum package. That's quite a bit. And today's session is intended to give an introduction to the topics and overview of all the topics, which means classes, courses, recordings, code, other resources that accompany this program. That's indeed quite a bit. So I don't want to wait any longer, and I want to dive into the agenda that I've planned for today. You see here we have 18 points. Some of them are a little bit longer, some of them are a bit shorter. What is at the core is point number 14, where we are going through a couple of case studies and demos to whet your appetite. And I must say in this context that this is not meant to be any kind of training session. So this is more for you to get a first introduction and overview as pointed out before. And don't worry if you see anything which might not be clear from the outset. That's not surprising probably, because we are going to cover all the topics that I'm going to demo later on and that we're going to discuss during this session in detail during the classes and during the formal 12 weeks of the program, which precede the practical phase as well as the final project. So we will have a quick introduction, then we discuss briefly the program. I then show briefly the Quant platform. We discuss finance with Python. There you can expect quite some new stuff in this context. Tools and skills, so important in this context. Python for financial data science, Excel databases, NLP, AI and reinforcement learning these days absolutely at the core of the programs. And then we have the core classes themselves. So Python for algo trading as well as Python for computational finance. And after we have then gone through the case studies and demos, I will also discuss more administrative and organizational topics before we then finish today's session with a brief discussion of the importance of practice. So for me, it's always very exciting to get started with a new cohort, because so far we have added always new stuff, have improved things that we have come up earlier, and this holds true here for this cohort as well. So I'm pretty excited to go with you through the next 12 weeks plus the 4 weeks of practice and final project. So quick introduction, just for those of you who want to review what we are all about, where we are coming from. So tpq.io, we have well more than 10 years of experience. Everybody working at my company as well, more than 10 years of experience in the field. Python for finance is a general topic, but around this general topic, we provide platform, open source libraries. I've written a couple of books. We provide the certification. Obviously, we run events, digital these days, but also live events, for example, in London, as well as in New York, for example. We provide services also to financial institutions, and training has become a core pillar of what we stand for. We've also developed a algorithmic trading platform, which allows you to easily deploy AI-powered Python formulated, Python coded strategies. What I always wanted to have is a one-click deployment, and this is what we have indeed achieved with the AI machine. So that's also driven by a dedicated team out of India. So for those who want to get a little bit more background, here are links. So this is not meant for us to go through in detail, but you have access to the slides, and with the slides you have then all the links to further resources if you want to follow along. Too long to be read here, but for those of you who haven't read about what I've been doing or haven't read yet my books, here the long version of my bio. Again, feel free to visit my personal page. So I've written a bunch of books. So my background is in quantitative finance, mathematical finance, a PhD in the field. And a couple of years ago, I started combining math finance with Python. And here are two books as an outgrowth of this endeavor. So derivatives analytics with Python and list of volatility and variance derivatives. These are more or less quant finance books that use Python. But the best-selling book out of the kind of lengthy list these days of my books is Python for Finance, which has become kind of a standard reference book around the world. And what makes me happy in particular is that it's also used around the world in many university courses, master's programs, PhDs use it, but also, of course, it is used by practitioners. It has been translated in Chinese, into Japanese, what you see here. So also happy, of course, about that one. These are my two books from 2020. I will say more about them later on because they are in part, at least, the basis for the core classes that we are going to discuss later. So the program itself, this is just to give you a broad overview what to expect in terms of numbers, not that much in terms of the details. This follows afterwards. So 16 weeks, thousands of lines of code, hundreds of pages as PDF and HTML documentation, hundreds of hours of instruction. So I'm not saying that in order to be successful with the program, everybody must go through every single piece of information that we provide, but at least you have the selection, right? For example, let's say we have a class about Python for Excel. For some people, this might be really exciting. For others, they might say, well, I'm not in Excel, maybe later on, but when I get started, this is not probably the most important topic for me. So we have the freedom, we have many optional resources as well, but for the core classes, you should really stick to the program. And this, again, means quite a bit of reading, quite a bit of coding, many practical things that you can do where you replicate things, where you have exercises and test projects to refine your skills and to gain mastery, maybe from orange belt to some brown belt level, and later on with the project in a certain field, even black belt level. So that's the basic idea there. And why is it so important? Yeah, because the financial industry today is at least as driven by coding than it is by financial theory. So I don't think there's not a single graduate in financial engineering, finance, corporate finance, or whatever the specific master's program is titled that has earned the degree without doing proper programming. So we have come a long way in the finance industry, and finance, which started out as a applied mathematical discipline in the 50s, we can say, is these days a computational finance discipline. And looking forward, it will be more and more so a data-driven, AI-driven, so machine learning, deep learning, reinforcement learning discipline, right? So, and therefore the big companies, they are looking for people who know about finance for sure, but who also know how to, for example, obviously here, that's the quote about know about Python programming. Python has become a standard skill, a key skill in the industry. Therefore, I think you are here with us in the right program. So graduates with tech and finance skills in high demand. Yeah, so it's computer programming these days. So a while back, it was maybe enough to say, well, I have gained mastery with Excel and PowerPoint and Word, so the Office suite. But these days, you need to be able to program, and you need to be able to use something else than maybe VBA, smaller VBA snippets within an Excel program. Not to say that Excel is not en vogue anymore, but the demands on the data processing and the analytical requirements have risen beyond what you can typically do with standard approaches and traditional solutions in the field, right? So finance will also need people who can work with robots, whatever robots means. This can be pretty abstract, right? Just like an AI agent, but it can be pretty concrete as well in the form of an embodied robot, as AI takes a third of jobs here, right? So job seekers with expertise in artificial intelligence, machine learning, data science are among the most in-demand candidates in finance. So we have over the years built a strong foothold in this area. Also, one of the outgrowths, you have seen it, my book, Artificial Intelligence in Finance, and you will gain exposure to many more content than what is in the book itself. For example, in the form of additional reinforcement learning resources, to name just one popular topic these days. So all what we provide you with, you have just seen the numbers, like thousands of lines of code, hundreds of Jupyter notebooks, hundreds of pages of documentation, is all delivered in a unique, consistent way. Unique on the one hand, but unified, I think this is the more important adjective here in this context, by our Quant platform. So we have built the first platform a couple of years back, and the new Quant platform was kind of finished, quote unquote. Such a project is never finished, but it has now the major features that we always envisioned towards the end of last year. So I think it's now working well. It's running robustly, which I'm pretty happy about. Maybe it's not perfect, but I think it's the right way to deliver all the content that we are providing you with, which is quite a bit. So everybody of you should have received login credentials. You will find there the latest videos, also all the recordings that are available. Depending on your program, this might vary a bit compared maybe to other delegates, and you also find the user forum, which should be your go-to resource when you have questions or maybe you want to discuss with others about topics that are of interest to you. And again, you find all the resources, and when I get into the first training class, Finance with Python, I will show you how the Quant platform looks like. But again, there are other resources like a brief introduction and overview video are available in this context, and we have shared this with you all already. Yeah, here it is, the link to the Quant platform. You see some 12 minutes roughly, and it explains how you work with it, how to log in, where to find the resources. But I will do maybe even a quicker review of how you can utilize all the resources to your best benefit in this context. Yeah, Finance with Python, that's already the first class, and this is a class that we have introduced quite a while back. The idea was to have a starting point for those who have maybe a strong finance background, but little or no experience in programming, or the other way around, for people who have a stronger programming background, but little finance experience. So we have many delegates which fit these two profiles. Of course, we have some as well, that's for sure, who have both finance and Python or programming experience, but this was driven by so many inquiries that we received who said, well, I know about finance, I'm a professional, but I just want to get started with programming, or the other way around, I'm a professional data scientist, I want to enter the financial field. So that's the background of Finance with Python, and it is what I call the gentle introduction to the field, where we cover fundamental financial notions and also the fundamentals of financial modeling, where we get started with the most simple setup you can imagine. Two points in time, so one period, you can say, and two states, uncertain states in the future that can materialize. And then we move on, but just a tiny bit, to a three-state economy in the future, and then a static multi-state economy where we generalize the state space, and we add the idea of dynamic economies, which is then more or less the standard, for example, in the context of option pricing. So although this might look a little bit more related to computational finance and the topics covered there, it's also pretty helpful and also very important, I would say, for what we do in Python for algorithmic trading. So basically for every corner of the rest of the program, this will help you pretty well, I would say. So you have then for the resources, as a general rule or guideline, typically three different areas, sections, or types of resources, we can say. So we have first, in general, a text, not for every class, that's true, but for the main ones. Then we have recordings plus additional resources. We will have live sessions, for example, for Finance with Python, which will replace these recordings because there will be some major updates in this context. And you have all the codes that come with such a class. Also on Jupyter Lab. So Jupyter Lab as an execution environment now has become standard. So the second generation, if you like, from the browser-based interactive development environment. So it started basically with IPython notebook. So I should rather say the third iteration, then moved on towards Jupyter Notebook. And now we have arrived at a fantastic solution, Jupyter Lab, which I think everybody in our field is pretty happy with, and which allows you, even without any installation of Python on your local machine, to just use the browser to access the reading materials, to watch the videos, and to execute the codes, to work with the codes, and to do your own coding, for example, in the context of the exercise. So all against the background of providing a gentle introduction to finance, Python, and the combination of both. So before I get to the tools and skills, I promise to show you briefly how to work with the platform and how to access the resources. So I'm already logged in here. So when you log in with your credentials, you see the latest video. So we just reorganized the platform and we have put in here the latest, the most recent introduction and overview from the previous cohort. This is not the latest video from the last round, but when you will log in, you will see first the last session that has been recorded and has been put on the platform. Also on the dashboard, you see latest forum posts. So here's something about the live data API, different results here, where somebody's asking why, for example, code executed gives a different output than the one presented in the book, back propagation neural nets, running the example. So you see here 4 posts, which are the latest one. This is not sorted chronologically with regard to the first post, but with regard to the replies as well. So when I would reply now, let's say to the 4th one, it would jump automatically to the first spot here. So that's the dashboard. You see, all pretty simple. It's not that much to navigate. It should just give you an overview of what has been posted and put on the platform latest. So on the upper left-hand side, this is where you find the main navigation. So it's usually not visible, just to provide you with as much real estate on the screen as possible. The first point here is the user forum. Then you find courses, trainings, and Jupyter Lab. So with regard to the user forum, when you go there, you will see that the whole setup changes. Again, you see the latest forum posts as before. And then you also see the topics, user forum here. We have Quant platform board, certificate program itself, finance with Python, Python for financial data science, Python for algorithmic trading, etc. I think this should be self-explanatory. When I go, for example, to Python for algorithmic trading, you see here kind of a bunch of posts. And when here you see a red new, it means that I personally haven't seen the latest posts. So sometimes there are many of these news because I read primarily all the posts by email. So every time you post something or you answer something in the user forum, we get notified automatically by email. If you have posted something, you are also in the email loop, but not for everything in this context. So for example, here, when I go to the first one, I could scroll down, and recently I've answered here a couple of things. There has been a follow-up. So you see how this basically works. If you want to reply to a certain post, just click reply, and then you are in the game. Or you go to a board and say just a new post. If you have a topic where you face some issue or you want to discuss something in this context, feel free to simply post. So here, boards, getting back to the overview, right? And then you can get started again and say, well, I have issues with the Quant platform. then the first big one here is the area where you should post your question. If it is related to finance with Python, what I want to focus on, then you would go here to finance with Python, create a new topic, and then you would be in the game. And recall, every time you post something, we get notified by email. So no need, no necessity to write us an additional email saying, I've just posted something on the user forum, please have a look. This is done automatically, right? So then we have the courses part, which provides you with the reading material. So AI in finance, finance with Python, Python for finance, as well as Python for algorithmic trading. And I go now to finance with Python. This is what I want to focus on because this is A, the starting point, B, something for this week. And you see finance with Python. And I said there is quite something new to be expected here. I just completely reworked, updated, corrected the whole manuscript. So January 2021, I did it over change of the year, actually. And you see here a standard structure, right? It's a relatively long document. It's an interactive document. When you say, oh, I want to jump, for example, to static economy, this, of course, is easily done simply by navigating the document. On the left-hand side, you see the table of contents, which is also interactive. And you say three-state economy is now the topic of the week, for example. Then you can jump in here and get started reading with chapter 3 if you have read already chapter 1 and 2. So in between, of course, you can also jump to the different spots, whatever is of interest to you. You can also search this document via typical browser search and find information, I think, rather quickly. So that's the first thing. And when you read something in the study plan, read chapter 1, read chapter 3, whatever. So chapter 1, you would go to Finance with Python, chapter 1, and this, when it says read Finance with Python, chapter 1, this would be the reading assignment here, which you can access on the platform. So here, there's not that much code in the first chapter, but maybe when I jump down to 4, let's say, after the introduction and a little bit of math, you see that it starts with the code here, right? And there's no need to copy the code here or whatever, I don't know, copy, paste or retype it or whatever. So you have access to all the codes that you see here. So when you recall my 3 different types of resources, this is the reading resource, and this is how you should consider this. Not to have it as a resource for code, this is a resource for reading, right? So I leave it for a second open here. You can later close it. The second resource we have are the videos plus additional code. And here you have Finance with Python, right? There are quite a bunch of classes, obviously. And Finance with Python brings me here to the class with the single recordings. At this stage, you have access to the original materials that are there already. So Finance with Python 1, 2, 3, 4. But as you know, we also will have live sessions over the course of this and next week, which will replace these recordings with new versions. This doesn't hold true for every class that we will do. So this is just now one in this cohort where we do major updates and have the live sessions in this context. So when you click, for example, on this video, it should start immediately on the platform. And of course, you can have, if you're like me and you have multiple screens. So I'm sitting here in front of 3 screens. So I could run, for example, on one screen, I could run a video, this video here. So, and maybe jump back and forth if I fancy. And in another, on another screen, in another window, in another tab of a browser, I can have open, for example, here, the Jupyter Notebook that is shown or that is live coded in this class. So that's the basic idea. You have the video but you don't need to do stuff sequentially. You can stop, you can have a look at the code. And when I say have a look at the code, currently I'm only sharing one screen, so I do it a little bit sequentially. I can also go here and have here the resources. When I click here on this Jupyter Notebook, it takes a few seconds because in the background now, in our back end, technologically speaking, Jupyter Lab is opened, which is called here Portal. And you see this is already from a while back. Finance doesn't change that often, and the Python code that is used here also didn't change that much. And you see, just by clicking on it, I now have Finance with Python demo, which accompanies this one video where I just clicked on, accompanies, and I'm here in the game. So this was now from the first one. I can go to Finance with Python, for example here, Finance with Python 3, and I can open another one here. So there are all the resources. So this is relatively easy to find, I guess. And with regard to replacing them for the time being, we will leave them here as they are, the original ones, and all recorded sessions will be posted in the live session classes. I can maybe show you this briefly as well. So here we have this class, Finance with Python. You have seen videos plus resources. There also here and there are links to slide decks that have been used, but under trainings, these are the ones here, CompFin, certificate live sessions, and PyAlgo certificate live sessions. There you find all the recordings, no matter for which class or which topic they are during the course of the program of the cohort. This is the place, or these are the two places where you will find the live sessions, and later on they will be replaced and reorganized. But from our experience, to have the recent recordings in a single place, in a single class, is basically what has proven best. So you see here, PyAlgo certificate live sessions, no module available, but once, for example, we have the recording of today's session available, this is exactly the place where you will find the recording of today's session. So here we have the codes. I have opened two, and you see they are not saving here. So in this context, because they are provided in a read-only fashion, but I show you also how you can save Jupyter notebooks. But I show you this in the context. Here, this is the training, but the other resources are found under courses. Under courses, you also find Finpi. And when I navigate to Finpi, you see here are 6 Jupyter notebooks. And these Jupyter notebooks are now exactly those notebooks which are used to write the chapters of the book. There are 6 chapters, and you find 6 notebooks there. We are here in the context of chapter 4. So if you want to have exactly the code that is used here, then you go on the here on the portal. You go to Finpi 04, and this is the Jupyter notebook, which is the relevant one for chapter 4, optimality and equilibrium. And you see now a quick comparison. Here, def you see, and down here until the optimal function value of 25. And when I go and compare this, you see this is exactly the code that you see here, right? From start to this point that I'm showing here, this is now what I've opened. Again, I cannot save this. It doesn't allow you to save it, but if you want to, for example, do some changes, some additions, or want to have your own copy to work with, you can go to File, Save Notebook As. This is also explained in the intro and overview video. And then you see here is the path, and I can simply delete what is up front here, finpi04.ipynb, just in the root folder. You see here is the slash, that's important. And now I'm not working with a read-only version. When I go to the top level, you see now that Finpi04 appears here in my personal root folder. And here I can now do whatever I would like to do. For example, say this is just a simple change of the notebook. And this is now something you can save here. You see here with a dot, it's not saved, but when I use Command S, I can save it here. And that's my version. So for example, let's say you want to put some comments in here, you want to work with different numbers, you want to change the examples, you want to rerun the whole thing then afterwards. So this works here. So I can, for example, restart the kernel and run it all. So now these are relatively simple notebooks. They execute quite quickly, and you see I've just now re-executed the whole thing. So this is now your version, and I've shown you how to do this. When you access resources that are read-only, you just go to File, Save Notebook as, and then you need to adjust the path to your root path, right? So that's the idea of how to work with the resources. Also in courses, something that is asked quite regularly. Let's stick to Finpi for this week. I know many of you want to have PDFs. We don't provide PDFs for every single tax, but for Finpi, there is the Finpi Course Pdf. When I double click here, it's quite a bit of a larger PDF with all the graphics, etc. And this is password protected. Everybody has received the password. And when I now type in the password, then I have also access here to the PDF file. This is something that you can download and use, for example, also on a pad like iPad or other pads if you prefer to read it locally. I don't recommend to print it because this is all in flux typically. There are many updates, etc. going on. So printing it out might probably leave you with a quickly outdated version, in particular, since I'm currently writing and working on this particular book here, the Finance with Python 1. So when you're finished with that, obviously you can close it. But you can also download it by a left click, example here, and then you go to download and you can save it for local usage, right? So these are the basics to work with the platform. Of course, when you want to work on exercises and want to try out things, you can also, here you see there is a launcher, and I can say, well, please open a new notebook. So I import NumPy as NP, our major tool for numerical computing, and then maybe we draw some random numbers, right? So of course you can use this to create new Jupyter notebooks on your own. You can also use it to open the terminal. This is a Unix-based environment. You see there are there's Anaconda, which was used to install. Notebooks is your working directory, so I would go to probably to Notebooks to work there. And you see here is my Finpi 04 and the Untitled one that I've just created in all the other resources. So for those of you who know already how to work on the Bash shell with Linux, this is your go-to place. And for everybody else, be assured after we are through the program, you will feel like an expert in this regard as well. So we cover the details required in this context in the program. For the beginning, this is nothing to worry about. I just wanted to show that you have the capabilities, or to use something like htop to control the resources of your Docker container. So everybody is working here in their own Docker container. And we also even show you how to set something like this up in your own Docker container. Yeah, this should finish it. So here, Untitled, this was just a little test. If I don't need this anymore, I would say, for example, here, delete. Yeah, I want to delete it. This was also just a copy. I can delete this also without risk, and I'm back in the original state. So that much about JupyterLab on the platform. Here the resources, and I have shown you also the videos here under trainings, where we have the current videos, but it can be relaxed. We have live sessions with new versions of all of this in this week and next week. Yeah, that much about the Quant platform at this point in time. So I said, after we are through the program, you will feel like an expert on the shell, and I think that's pretty much true. And among others, the tools and skills class is your helper, your bridge in this regard, if you are not yet an expert in this area. So we cover all the required tools and skills to set up a proper Python environment for Python development, as well as deployment, for example, in the cloud. So we cover the basics of Python installation environments on Mac and Linux, as well as on Windows, Docker usage, including Jupyter Notebook Lab on Mac, Linux, and Windows, as well as cloud usage from Mac, Linux, as well as Windows. And as we go, we will cover here and there additional basic Linux tools and shell basics, but the focus will be on the following tools. Vim for quote-unquote universal code editing. So I use Vim on every platform, be it on Linux, be it on Mac or on Windows. Vim as an editor is available in all environments. And even if it might not be my major editor, for example, when writing a book, but for quickly editing code and working, let's say, on a cloud server, this comes in pretty handy. And when we then combine Vim with Screen, Session Manager, and Q, a little tiny Python package, we have what I call a lightweight tool chain for editing, logging, and debugging. So I'm a big fan of that because it is installed within minutes, if not seconds, and it's pretty lightweight. So this is like, it comes out of the box. It has a panel screen management, comparable to more sophisticated local environments, etc., etc. So bear a little bit with us. This will come early enough for you to be productive and ready to get used to it. Then we also cover doc test and unit tests, an important topic, Git version control, which might in the beginning not be the most important topic, but later on might be pretty helpful. For example, also in a corporate context, or when you want to work on a larger project and want to properly manage versions of your project, or want to work together, collaborate with others. This is something that comes in pretty handy. And if you then go one step further and want to distribute your Python code in the form of a package, let's say, we cover here how Python packaging works on a basic level, also how to come up with a proper modern documentation, how to host the code, let's say on GitHub, or with, of course, additional alternatives available, but GitHub is and remains the most popular site. And then we have also a case study which tries to combine all the other tools into a single coherent case study, so that you see how the single elements interact with each other. And what we do there is, work with Jupyter Notebooks, Terminal Editor, IPython, Vim on every infrastructure. So what we cover will be repeated a couple of times, but in different contexts. Of course, we need Python on the programming level. There might be a Docker container involved. There's no necessity for that. And we will also learn how to put all this into the cloud. In particular, when you deploy your algorithmic trading strategies, you should do this on a proper, reliable, robust infrastructure. And these days, there is no argument from my point of view against deployment in the cloud, because you can get started with $5 per month. So this is for sure, I would say, if somebody wants to do proper algo trading, this can't be a barrier of entry in this context. Also here you will find videos plus additional resources, maybe a little bit differently structured and prepared than for the other classes, because here we provide more scripts and cheat sheets for the different tools, etc. So, but this gets started from early on, and you will have exposure from a basic level, a gentle introduction to the more advanced topics as we go through the program. Then we have the Python for Financial Data Science class, which is based on my book Python for Finance, and in particular on the first 13 chapters in this context. And this is about all the approaches, tools to some extent, but primarily about the packages. That's the focus here, that are so helpful and maybe even required to do proper Python for finance. So we get started with the basic Python data types and structures. We then introduce thoroughly NumPy, move on to data analysis with pandas. OOP is introduced, not on an expert level, but I think on a work level that should be enough for the other instances where you might want to work with OOP in the program, or should work with it. We then have the data science focus, visualization, financial time series, input-output operations, of course, efficient ones, and Python, I think, is a master in the field of performant I/O operations, as well as performance Python. So when I got into the Python ecosystem, I heard it, it feels like on a daily basis, the Python is too slow for finance here and there. I think we have come a long way, and we have fantastic performance packages and libraries available which allow to come up with Python code in certain instances which is comparable to C code, and for sure comparable to the performance of other languages such as Julia. Not in every instance, but I would say in many instances, with the elegance and concise approach of Python itself. And then a little bit more mathematics, about mathematical tools such as SumPy, differentiation, integration on the command line, quote unquote, stochastic, simulation, risk management, value at risk, statistics, and machine learning. And last but not least, we have dates and times, which are so important in the financial domain. So statistics and machine learning here is meant as more an introductory session. We have throughout the program, from start to finish, many resources which are related to machine learning, AI in general, and AI and reinforcement learning applied to the financial domain. Yeah, the resources are similar. So you have the reading, not the book itself, not a PDF, but you have the HTML version of the 13 chapters. You have the recordings, you have Jupyter notebooks, and maybe other files, data files, code files, or whatever that accompany the sessions. Plus, you have, of course, the single Jupyter notebooks that you can execute on the Quant platform in the Jupyter lab part in this context. So this is the typical triangle of resources that I mentioned in the context of finance with Python. Then Python for Excel. This is one of the optional resources. Again, I think that not everybody is primarily interested in using Excel, but many in a corporate context are. And this is a class where we show how to combine Excel beneficially with the analytical power of Python. So just think of a powerful and simple, straightforward replacement of VBA with Python, with all the wonderful things that it can do in Python, but which might be triggered and displayed and how should I say, coordinated from the Excel level. Isn't it wonderful to say, well, I click a button and then there are some sophisticated analytic steps involved in the back end, and I'm not even taking care on the Excel level about this, or think of machine learning applied to data that you have in Excel or whatever. So the application areas are basically limitless, and it works to a large extent on Mac as well, but not to 100%. So in order to benefit completely from what Python can do for Excel, a Windows environment is required, but let's say 60% can also be harnessed on a Mac installation. Python for databases. Finance is a data-driven discipline these days, and therefore, no wonder databases play an important role. We cover in this optional class SQL and NoSQL databases, as well as Python specific. So there is some MySQL, there's SQLite, MongoDB as an object-oriented store, PyTables as a hierarchical database for binary storage, SQL Alchemy as an abstraction layer for SQL-based backends, as well as Beagles as a columnar data store. So all fantastic solutions. Maybe not every single one, as before, is of importance for your specific goals or your work environment, let's say. But I think no matter what your use case is, you will find one or the other solution which might prove helpful. Here again, the resources are structured a little bit differently. We provide, of course, videos, additional resources, explanations, etc. But here the focus lies on helping you to install everything in the cloud. So therefore, this starts a little bit later, once you have had exposure and a little bit of experience with setting up a cloud infrastructure. Because if you want to install everything that's required, for example, with the MySQL, etc., this is quite involved, and we simply want to avoid that anything your local setup will be messed up with, right? So, but you will see what I mean later on when you dive into that. Then we have an admittedly brief class, 2 recorded sessions about natural language processing. Maybe we could add in the future a little bit to that. But with these 2 sessions, we cover already quite a bit of ground. If not 80%, but maybe a little bit over 50% of the most useful things that you can work with in this area. And it helps you, for example, with summarization of texts. I do it every once in a while when I have a couple of research papers. I simply transform PDFs into text or HTML and then use an NLP with Python to come up with word cloud summarizations and stuff like that, right? Just to automate a couple of things that might be helpful. I wished I would have had something like this when I was back at university, that's for sure. But we've come a long way, and today we can benefit from these fantastic new technologies. And obviously, we have, I would say, quite a bit more unstructured data in this world on the web, in particular, than we have structured data in the form of numbers. And there is already quite a bit of data in the form of numbers, like time series data, cross-sectional data, etc., available. So we are talking about petabytes and petabytes of data out there. But again, Python again here is one of the go-to languages at all. If you want to do proper NLP, Python is pretty fast in this context, and I think we have the right programming language here to help us with not only crunching numbers, but with also crunching unstructured data like text in this context. So then we come to one of the core topics, artificial intelligence in finance. It has become so important in the field, and there's quite a bit of hype. And I like to say that we are still here at the nascent stage. So there have been, maybe a number already, admittedly, of success stories in the field. Not as successful as when you think back in terms of AlphaZero or whatever you're aware of, or AlphaGo, so to say, where there's a Netflix documentary for the success. But there are already success stories, but still, I feel that we are pretty much at the beginning of all this. And this is my formal beginning, if you like. My take on AI in finance with a focus. It's a couple of hundreds of pages, and still I focus only on one particular part, which is related to algorithmic trading in this book here. So there are many other areas, like in computational finance. You might have heard of deep hedging, for example, or in the areas of credit scoring or fraud detection, etc. There are many useful application areas which are more or less revolutionized, we can already say quite now, by the application of AI techniques, and we will see more progress in this regard in the near future. So I think it's the right time to get deep into this particular topic. Because when we think in terms of financial markets, we can think of financial markets as a huge abstract data processing engine, right? So we have X, which stands here for input data, and we have Y, which is the output data. Let's say this is some news, some political news, business news, economic news, whatever it might be. And the markets process it, and we see the results in the form of adjusted prices, index levels, etc. But the way this happens is for sure non-linear, it's complex, it's changing over time. So in other words, we are not dealing with the physical world, where the physical world, at least to a large extent, once we have found a law, like F equals M times A or E equals MC squared or whatever jumps to mind in the physical world, this is usually there to stay forever. Once there's proof for that, mathematical proof, and it relates to physical reality, then it's there to stay forever. In finance, I think the world is a little bit different. So when you pick up a finance book today, many of the theories have been in finance books already at the end of the 60s, 70s, 80s, etc. So brilliant people have come up with what I call normative economics approaches, where they assumed how people might behave or assumed how markets should behave, etc. Then they came up with simple, elegant theories. Just think of the capital asset pricing model or the many other simplified theories. They usually rely on two major assumptions: that relationships are linear, A, and that returns or other quantities are normally distributed. But both of these assumptions are in general wrong. Therefore, these elegant, nice theories, which I'm a big fan of, really, I love traditional finance, don't get me wrong in this regard, but most of these fantastic theories, elegant theories, have hardly any supporting empirical evidence. So this didn't work basically from the beginning. So it's not that something has changed later on. Even from the outset, there has been hardly any supporting evidence, for example, for the capital asset pricing model. The word is simply more complex than returns of stocks. Think of Apple might be explained by the return of the major market index and the linear relationship. So this doesn't really work. So therefore, with AI in finance, we can get back to positive economics. We say, well, let's get started with the data and let's figure out relationships that might be in the data. So we are more like physicists doing an experiment, and then we apply general parameterizable trainable algorithms. This is now the AI part, and we might come up with some complex neural network, a number of hidden layers, many hidden units, etc., which might not be as elegant and as concise as the traditional original finance theory, but which might be better in practice. And if you ask me whether I would prefer a simple, elegant theory or a little bit more complex one, which I don't fully understand, I would prefer the complex black box if it makes me money, as compared to the elegant simple theory, which I fully understand, but which is not in accordance with reality. So that's the basic idea from my personal point of view behind AI in finance. On a more practical level, this is yet another class, and we have two classes. When we get to the study plan, I will explain this again. So we have one class. This was the starting point with the formal AI in finance class, where the focus lies really on starting from scratch and building bottom up many models based on Python code. So this is really like your go-to resource, the original artificial intelligence in finance class. When you say, well, I'm really interested in how neural networks work, what backwards propagation is, how this translates into practical applications, etc., the basics also of the single packages to be employed. So this is your go-to resource. But there's also another class which we did in the last round, which relates to the new version or the final version, so to say, of the book. So you have like for going forward for the next 12 weeks, you have the major class, which is a recommended resource, and which is called AI in Finance book. And you have the original class where it all got started, which is an optional resource. So for those of you who are interested in particular in this field, you might want to follow along the two of them in this context. We have also added recently a separate class for reinforcement learning, because I think it's not only myself who is so fascinated with reinforcement learning for finance, but many others as well. And we just recently had the first final projects in this field. And when I said AI in finance is at a nascent stage, I think this is even before that. So this is like an exploratory stage, I would say, but nevertheless, a fascinating one. Fascinating for me because one of the first success stories in this context was by DeepMind in the context of playing Atari games and later on AlphaGo, but playing Atari with deep reinforcement learning. When I was growing up, this was one of the first consoles to play card games back home. And I was so intrigued by that, like everybody else my age, I think. And suddenly DeepMind comes around the corner and they have an AI agent, a deep reinforcement learning agent who plays these games at superhuman levels just by playing the games and learning game for game for game. This was so intriguing. The same approach was then used, of course, much refined for AlphaGo and later for AlphaZero. What we are going to cover, and I think a little bit of fun has its place here as well, are a couple of games based on the OpenAI Gym environment. Card Pull as a simple entry game, then we have the mountain car game, and a little bit more complex and not that easy to solve as the others is Lunar Lander, a game that I recall playing myself back then as well. So here gaming and a little bit of fun is also included in the reinforcement learning class. Of course, with the goal, once we have understood the approaches and have code available, which is able to learn playing of these games, that we can then benefit from the experience and go to the financial side of things. So here there are links behind that where there are recordings. So here's a Lunar Lander. You see how this works. This Lunar Lander thing there. It's not probably the best agent. It takes quite a bit and a while. It's not like a perfect agent which immediately lands the spaceship appropriately between the two yellow flags. So here you see it takes quite a bit, but I think it's fun to see how an agent can learn how to fly such a spaceship with this in this interactive environment, and then how we translate all this into trading in the financial markets. Pretty fascinating still for me when I see this. So you see, this is a slow agent, takes quite a bit, but in the end, now I think it's landing and it's not crashing. That's the basic idea, and it comes to rest between the two flags here in this context. So there are links to these little demos in the slide deck as well. Also for Mountain View. Maybe we have a quick look. Now they're getting so excited when I talk about this. This is a little bit more easy. Here it's just a momentum game, right? I need to push as hard as I can to the left to get enough potential energy, which is translated into momentum. And then the goal here is to get out of the screen, so to say, to reach the yellow flag on the right. So when you get started with that, it's not as easy as it looks right here, but it's also a good starting point to learn about reinforcement learning. Yeah, this is what to expect in this class. The resources themselves are then quote unquote more standard videos, the notebooks as well, of course, as the stored notebooks on the Jupyter Lab site here in this context. So this is all available on the platform as all the others. And you see the subtitle here, from playing games to trading in the financial markets. Now coming to the core classes. I wouldn't say that the core class is based on the book. The book is an outgrowth of what we have been teaching over the years, but we have more in the program to offer than what is to be found in the book. You see here for the core classes, I have listed again here finance with Python. So for everything that follows, it is expected that you have a good grasp of these topics, as well as a general class that we have for the introduction part during the first 3 weeks, financial data science. Then we come to the topics themselves, like vectorized backtesting, prediction-based trading, where we apply machine learning, deep learning in this context to come up with strategies. We then introduce event-based backtesting to have a little bit more flexibility, and then algo trading itself. So up until that point, we just deal with data and ideas and do some backtesting, but there is a point in time when you say, well, now let's go live. And at that point, you need to be able to deal with real-time data and streaming data, also maybe with streaming visualization. In this context, we cover 4 platforms: Wonder, FXCM, Interactive Brokers, and Gemini. And we put it all together in the automation and review part, where we say, well, now let's put it all together, do some backtesting thoroughly, and work with a platform, transform our offline strategy, as it's called, to an online one, which is applicable and deployable in a real-time context, and all the elements that come at the end, and that is so important, are then here put together in automation and review. Then we have the practice modules, where you should come up with your own strategy. Then the practice module 2, which is about deployment. And based on your experience in this context, you might then be ready to come up with your final project, which is a research paper. There's nothing to be done here about deployment. It's actually forbidden to do something with APIs or deployment. It must be reproducible from A to Z. Here, my pyramid that I use since years, and I haven't seen any reason or incentive so far to change it. So we start with the infrastructure for everything. Financial data is required, otherwise everything will be shallow. Strategy code is to be formulated. Backtesting code is to be added to the mix, and the connecting code to the markets, where we then interact with the real-time world with streaming data. We then need to be able to execute trades. This is what is meant by trading codes. And last but not least, all this needs to be put together into a coherent Python code base that we can deploy in the cloud. And this is then shown here in the form of integrated case studies. So then we have also a Wanda masterclass. So Wanda is indeed a focal point in this context, because from my point of view, they have the best technological infrastructure. And there might be a path for those of you who are really eager to become early adopters, testers, beta testers for our platform, but more on this later on. First the program, and then we'll discuss these topics if of interest at all. Python for Computational Finance, that's the other core class. This is about options, to keep it short, options and derivatives, right? And this is primarily based on my book, Derivatives Analytics with Python. Right-hand side, you see the Chinese translation of the book. And we have these topics here. So we have the basics about market-based valuation. Everything that you have learned in Finance with Python comes in handy here for this. When I say Finance with Python is expected for the Python for Algorithmic Trading class, this holds true even more so for computational finance. So indeed, Finance with Python must be there as a basis when we get into the world of computational finance, because here we skip over the basics, at least to some extent, or I'd rather say we don't spend too much time on the basics, to put it that way. Therefore, Finance with Python should be there already. We cover complete market models like Black-Scholes-Merton, Cox-Rubinstein here, binomial option pricing, risk-neutral valuation, the more general framework which originated at the end of the 70s. Fourier pricing is introduced for efficient calibration approaches. We then cover American options based on Monte Carlo simulation. Numerically quite involved topic. General market model is covered, which means a model which allows for stochastic short rates, stochastic volatility, also jump components. So that's really at the core, because from that point on, everything else is based on this general market model or some sub-model, some specific version of the general market model. And we cover Monte Carlo simulation, then efficient Monte Carlo simulation, of course, calibration of these models, hedging strategies based on numerics, and we do some review and also have practice in this context. That is a good question, which relates to algo trading. What's the difference between step-by-step and the platform, the AI machine? To keep it short at this stage, more on this later on in the program. The AI machine is basically when you have a strategy and you want to have standardized, robust deployment. You formulate your strategy on the AI machine and you have a one-click deployment. When you do it step by step, and this is what I would require from everybody who wants to work with the machine to understand what's involved, you need to take care of so many things that the platform takes care of, right? So it's a little bit like we teach you how to build a car, but you can also, of course, go to a car dealership and say, I want to buy this used car at a cheap price, and that's exactly what I've been looking for, and then you drive away with it. But we more or less have the idea that first you need to master the skills, you need to understand what's involved, and then you can properly work with a platform like the AI machine. That's as a quick um, um, excursion here from computational finance back to algo trading. Yeah, computational finance, but that's not all, so to say. We, in the last cohort, have introduced, basically for the first time, although this book is available since a couple of years, one of my quant finance books, we have for the first time had a class about listed volatility and variance derivatives. Very interesting topic for those of you, and in particular now that we have seen what happened in 2020, where volatility again spiked to levels we've never seen before. And yeah, this becomes so important as a risk management tool and also as an asset class for sure. I thought this would be so timely, and we had a couple of fans of the topic that said, well, yeah, we would be interested in. That's the reason why we just added this class in the last cohort. So this class is about trading volatility and variance as an asset class. So we have an introduction there into the world of derivatives, volatility and variance. The core topic here is the model-free replication of variance. We then cover volatility, products in detail, but first volatility itself. We've got the data analysis strategies and the VSTOXX index. This is all based on European derivatives, but the VSTOXX index has the same definition, works the very same way as the VIX, for example, as well as for the other instruments written on the index. So when you read VSTOXX from a theoretical, conceptual point of view, you can replace it by VIX. In this context, then valuing volatility derivatives, also advanced modeling of the VSTOXX index using jump components as well. Then variance, realized variance, and the variance swaps, quite popular, not as listed derivatives, but over the counter for sure. Variance futures at the Eurex in Europe. And then we also apply DX analytics in this context, my package for pricing options and complex portfolios composed of derivatives, right, based on square root diffusion and square root jump diffusion. And we then have a couple of add-on topics here in this context that are not at the core, I would say, but which come in handy if you want to review certain elements. So not a brand new class, but a new class from the previous cohort. DX analytics, I mentioned before, is something that we cover in detail, in much more detail than in Alpha 4D. In the LVVD class, Alpha 4D was German, so in the LVVD class, there's the volatility and variance derivatives class, and this is basically in line with the core computational finance class. So basics with a quick start, the framework, European valuation, portfolios, Fourier pricing, American valuation, stochastic short rates, derivatives portfolios is something that returns after we have added additional twists to our modeling capabilities. And then we have some specials there like multi-risk derivatives, implied volatilities, calibration, hedging, and last but not least, complex portfolios modeled and valued with DX analytics. So that's a class that goes in parallel with the core class in computational finance based on the book Derivatives Analytics with Python. Here you see the schema which explains the idea of DX analytics. It's about the risk neutral present values and creeks for instruments, positions, and portfolios. We only have Monte Carlo simulation as the major numerical method. Other methods are quote unquote only helper methods, such as Fourier pricing. For example, we have forward simulation, backwards propagation for the valuation. We have the non-redundant modeling of risk factors. We can have multiple derivatives, simple ones, or multi-risk derivatives, European exercise, American exercise, plain vanilla payoffs, complex non-standard payoffs. We then can model positions as well as compose portfolios thereof and take into account net payoffs. So risk neutral discount curve can be constant deterministic or stochastic. So more on this. This looks maybe a little bit complicated, but the single elements will be explained in detail in this particular part. Yet another pyramid. This time we have 8 topics. All starts with the infrastructure. If we don't have Python, if we don't have the DX Analytics package, NumPy, Pandas, etc., it doesn't work. We also need financial data. We need the models themselves. We need to be able to simulate the models efficiently. Fourier pricing is an important numerical method which helps us with the calibration of the different models, so helps us in terms of speed, efficiency, and this allows us after calibration to come up with market-based valuations. And last but not least, in turn, this allows us to also do proper numerical hatching based on the calibrated market consistent models. Yeah, now it's time for some quick demos. I said it already before, this is not meant to be a training session. This is just meant for you to gain a little bit more insight into what to expect, as well as to whet your appetite. So don't try to follow along in this context. I have already shown a little bit about the Quant platform. So I will therefore jump into the second point here, Python with Docker. And I just want to show you, if you've never heard of Docker, if you've never used it, if you work maybe with Linux, that it's all but a secret actually to get into that. So I have already prepared here a terminal window, and you see there is a command docker run -ti -hcert -v. This is currently not the important part. So everything is explained in detail. The only thing that needs to be assured is that Docker is installed and running. So here you see Docker desktop is running. So without that, I couldn't do what I'm now going to do. And if you wonder what Docker is, if you've never heard of it, maybe you've heard of it, but I haven't had any exposure to it, this allows me personally now here on my local machine to run a Linux operating system, and our go-to choice is Ubuntu on a Mac OS. So you recall when I said Jupyter Lab on the Quant platform is provided to everybody of you within a Docker environment. I now do the same quote unquote here locally. So when I execute this line of command here, docker run, etc., you see it suddenly says root cert. So before I was in the Mac world, Mac Live is the folder, Eve, I'm the user, right? And work is my Conda environment. Now I'm in the Linux environment. So you see typical folders. For those of you who have experience with Linux, that's like second home, I would say. For those not, again, my forecast is that after the program, you will feel like home here as well. I now navigate to the root folder. So I'm logged in here as the administrator, the root. This is, so to say, the master of the system. So I go to root, and given my command, how I started this was a little bit quick. You see I have one folder here mounted, and this is from my local system. So when I look up what is in there, it is live. So these are a couple of Jupyter notebooks that I want to show you later on for the demo. Currently, we shouldn't be too concerned with that. So when I type in Python here, it says Python not found. So my major goal here is to come up with a proper Python environment that would allow me to do some, let's say, finance with Python and Python for finance, to keep it simple to these two topics. So first of all, what I need to do in general is an update of the package index. This is something like on Windows where you say check for updates. Then I do the update, get upgrade. So it now says, well, there's a bunch of things that can be upgraded. Do you want to do so? Yes. And again, this might now be fast, but it's just to illustrate it, not to teach it, nor for you to understand or follow along. Now I have done my housekeeping. Next thing that I need is I need to retrieve a Python installer. And to this end, I need a tool which is called wget. Oh, I need to, of course, type in install, apt-get install wget. Install says to the package manager that I want to install a certain package. Wget, when it exists, is then here looked up, and I'm prompted whether I indeed want to proceed. And I now have wget, and this is a tool that allows me to retrieve remote resources. And here I want to work with Miniconda. This is something that we use throughout the program. It is a package manager, it's a minimal Python installation, and it also allows us to manage environments. So this all is explained in detail in, for example, tools and skills, but in other places as well. You see here there are Windows installers, Mac OS installers, but now recall I'm in a Linux environment. So here Python 3.8, there's also the option 3.7, but I go with 3.8 64-bit, copy a link address. And now I can say that's the reason why I installed wget. I paste here the link and I'm going to retrieve the package. It's, I don't know, 190, 89 max, depending on the speed of the internet connection. This might take a little bit longer or might even be faster, right? And I now have this available here, mini conda, right? So minus AN. When I have a look here at the full, you see there are also some hidden files, but this is the large file here, the installer, and here we see the size, 94 max, something like that. So now I executed bash miniconda, and this will install Python. In order to continue the installation process, please review the agreement. I've done this a couple of times, so I don't need to read through this here in detail. I simply jump through the text and I say, yes, I agree to the licensing terms. Now it prompts me where to install Miniconda. I simply go with the suggestion, root Miniconda 3. What's now going on is that it installs Python plus a bunch of other things. So you see here SQLite, there's an SQL database, batteries included with Python, and a couple of other things, OpenSSL, so for encrypted communication, for example. Now it says, it asks me whether to initialize Miniconda. I say yes, and thank you for installing Miniconda. You see, this was a quick affair, I would guess, right? And when I now type Python, it's not yet there, so my major goal not yet achieved. What I need to do, I need to restart my bash shell by typing bash, and you notice immediately it now says base. Before it was just root at third, now it says base root at third. And I can do stuff like conda env list, and it shows me the environments, base. You see here conda environments, base is there, and it has installed Python in this context. When I now type Python, suddenly I have Python, right? Hello quant world. And my first line of Python code, my hello world example, right? So I can exit this, so typically we won't use it, and I can now use conda to install other packages, IPython, NumPy, I go with it, and maybe also Jupyter Lab. So IPython is a tool, Jupyter Lab is a tool, NumPy is a package. More details as usual, I repeat myself. I just want to make sure that you don't think you're missing out on something here. Conda install IPython, NumPy, Jupyter Lab, and it now connects to the server, checks for IPython, NumPy, Jupyter Lab, and it comes back with a list of packages that it asks me whether indeed they all should be installed. Because when I install NumPy, for example, or Jupyter Lab is an even better example, it's not only that Jupyter Lab gets installed, you see there are a bunch of packages. This is what are called dependencies or requirements for certain packages. So I say yes, and it's now downloading stuff. Again, speed of the internet connection plays a role here. For example, this one package, 130 megs, it's a little bit larger, and it's done. So now let's check. I said Python is typically not what we use, but IPython is something that I use pretty regularly. This gives me also a Python interpreter here, Python 3.8.5, and interactive. So print hello quant world, and my first line. You see, among others, that I now have numbered input prompts compared to before, and I have syntax highlighting here. Print hello quant world, obviously highlighted in green and brown or whatever this is, beige. And I have installed NumPy, so import NumPy as np, for example, and np random.random, maybe 10 or 19, I don't care. I draw 19 random numbers. So NumPy is there, IPython is there. So I have already accomplished quite a bit in this regard. And you recall, I've shown you a couple of times how to open a Jupyter notebook on Jupyter Lab on the Quant platform. But now I'm basically only one command away from having the same here. I can start Jupyter Lab. Here I need to add a few little twists explained later on. Port 999, this is something I specified, and I need to allow root. This is to circumvent a certain security mechanism here. So I have installed Jupyter Lab. I hope it runs, and it runs here. And I see here the line that is of interest. So that's the URL that I need. And let me use this tab. I don't need the installer anymore. And now I'm opening Jupyter Lab here in the browser. This is within my Docker container from my Linux Ubuntu environment. And you see I'm up and running. And here, this is a folder that I have mounted to my container. These are the other notebooks that I'm going to show you afterwards. And when I open, for example, the first, you see my Jupyter notebook opens here. I cannot really execute it right now because I've only installed NumPy. Here you see this requires pandas and matplotlib and a couple of other things. But with regard to the tool, we are good to go. So I'm going to discard the changes. You can also edit text here. So I see this is a markdown document that I use to share the gist, the resources with you all. And you see I can do some text editing. And as before, I've shown it on the Quant platform. You can go here also and have in the shell in one tab here, you have the terminal. So when I want to call htop, it's not installed. So I can from here, what I did before, apt-get install htop. It's another package like wget. And when I now call htop, you see I can manage my resources. So I have 6 cores here. The memory that's allocated is 2 gigs of RAM, and I see all the processes here running. So like a matter of minutes, and within a Docker container, I've installed Python, IPython, Jupyter Lab, and have done already my first things here with Jupyter Lab. Just for illustration, this is all what you will learn and what will become, I'm pretty sure, second nature once you have gone through tools and skills and the other parts of the program. So I can leave this in the background, can leave it running, no problem with that. But I now go to a local Jupyter Lab. So what I've done here in a fast fashion, I have of course here already pre-prepared and yeah, by default installed on my MacBook, and I can now open this notebook that I've shown you before briefly, and here I can execute it because everything else that is required is installed there as well. And this is a little demo notebook about the efficient market hypothesis, random walks, couple of quotes. Again, I'm not going to spend now that much time. I just want to show you when I walk through this notebook, I retrieve here data. This is a standard data set that I use regularly with a couple of name symbols, or RICs as they're called in the refinitive world, in here. So this is data of 10 years worth of end of day data. So standard data set, also from the Python for Algo Trading book. I calculate some log returns, daily log returns. These are small numbers. I plot the data here. See, this is nicely plotted with Plotly interactively. So I can even go, for example, and turn off Amazon and maybe Apple. So you see immediately it's dynamically adjusted. You see, for example, here the VIX in the rebased way, for example, over time. So I can click out or I can zoom in. This is all fantastic with iPlot. iPlot is the call here, but with Plotly is the package, and Cufflinks is the package on top of that, which makes it all available. So I can also plot histograms for all my easily for all my calculated log returns. What is also nice usually is the correlation, the heat map here. are the correlations. You see like one, of course, every instrument has a perfect correlation with itself. There's not that much of an insight, but you see, for example, that the VIX is not that much correlated, basically not at all here, or it's wrong what I said, so my wording was wrong. So we see here the lowest correlation, which means is not zero. I mean, if I would say not correlated, it would mean zero. But when I see white here, this is like close to -1. So that's now it's highly negatively correlated here in this context. So easy to generate heat maps. I'm preparing lag data, something we will repeat over and over again. We will work pretty regularly with lag data in this context. So where we say, well, if we want to predict the Apple stock price, we, for example, work with 7 historical lags in the tradition of technical analysts, where you say, well, we have a look at the historical price formation. We try to work with the price formation in order to predict next day's move in this context. So that's the idea in this context. So then we apply here a standard tool in econometrics, OLS regression. I do the regression here via a loop for all the instruments. Here you see the numbers printed out. And with regard to the efficient market hypothesis, what I emphasize typically here is that only lag 1 is important. Everything else is unimportant. This is pretty much visualized here, where you see when I have a look at the historical price formation. So lag 1 is last day's price, 2 days before, etc. What it shows here with ordinarily scarce regression, there is it's just lag 1 which plays a role. Everything else doesn't play a role. Among others, technically, this is due to the fact that these lags are that we're dealing with non-stationary data, and the lags are highly correlated. But that's a different story, and this is discussed in detail later on. So there is another chart which now gives the averages, or we can apply a more sophisticated linear regression here in the form of the stats models, OLS, ordinarily scarce regression. And you see we get a bunch of statistics here, like R squared, adjusted R squared, etc., etc., etc. So just like to show, this is something we cover in detail, efficient markets. There's a question with regard to getting API data from Icon for the next 12 weeks. Unfortunately, I don't have by default such an option to provide you with access to that. But if they are more interested, basically you don't need it. You really don't need it to go through the program, not until week 12 or even beyond that. But I know that everybody's eager to get data. And I also would say, if you have 12 weeks access to the data, what do you do afterwards, right? If you want to deploy your code. But I can speak to my friends at Refinitiv if there is some easy way to get your hands on a free trial in this context. I don't want to exclude it, but I cannot promise it, because I don't have something here out of the box or any kind of agreement that I can share. Maybe you can ping me afterwards again, and I try my best to get something accomplished for you in this regard. Yeah, this was the first Jupyter notebook. So let me simply restart and clean it up. Then, when we speak of efficient markets, we have two sides of a coin. The one side might represent the view of the financial engineer and financial modeler. The other side of the coin might be the view, or represent the view, of the algo trader. So when I'm a financial engineer and I'm like in option pricing, derivatives pricing, risk management, etc., I would say, maybe, thank God, markets are efficient, and this allows me to price complex options based on calibrated models. Because the basic idea is the market is always right. If I can figure out the proper martingale measure, to speak technically, then I'm on a good path for like proper valuations and risk management strategy. So here, this is now the notebook from Computational Finance about a Merton jump diffusion model, where we simply take the financial engineer perspective, where we say, I don't go into the details here again, where I have this model, I have some initializations, and then I calibrate the model here based on a root mean squared error, where I say, well, I want to come up with parameters for the model that minimize the root mean squared error given the market prices of options. And typically you wouldn't deal here with 100 options or multiple dozens of options, but a smaller subset, maybe 3 majorities and a bunch of options around the at the money level, maybe forward at the money level, right? Here the example is based on Eurostoxx, and I make a couple of assumptions. I work, as I said, with a smaller subset of options. Here you see the strikes, the call prices, the majority, it's data from 2014, the put prices are in there. And now I simply show here the call options, and the idea of calibration, there are maybe variants to that, but the idea is to come up with model parameters to best replicate these prices. So these are market prices. And in financial engineering, more often than not, you would say, well, I want to best replicate the prices of plain vanilla liquidly traded options to then go from there. So, and to this end, we define an error function. We get started with a global minimization where we scan the parameter surface. And it's taking a while. So we are doing here a bunch of revaluations. So hundreds of options are evaluated over and over again. So this takes a bit for sure. This is dependent on the hardware and on the number of options, on the methods that you use. The total length, of course, is also dependent on the parameter ranges that you scan here. So that's not the big thing, right? And in the meantime, I know I've been talking about icon, maybe a test access. Where we are in the context of computational finance, many people ask me, where do I get free data for options? So if it is already difficult to get free data, I mean, free alone, we are in the financial world, right? Free alone has its, at least its strings attached, whatever they are. But free options data is even more difficult to get, and even for like trial accounts with icon, I would doubt that there is lots of option data available, because there are different licensing models involved in this context, which prohibit the widespread distribution of such data in this context. Yeah, so just as a word of caution in this context. So after the global optimization, we go to local convex optimization, and we see that our root mean squared error is getting smaller and smaller. It's not zero, so we wouldn't expect a perfect result here. So after brute force, we have 0.97, and after local optimization, 0.76. So slight improvement. With a little bit more effort, we might get better. So, and now it's the point in time where truth is revealed, and you see the blue line is now representing the market quotes, and the red dots are the model prices. In the upper subplot, it looks almost perfect, but therefore I've added like the lower subplot where we show the differences. The differences are not too huge. So here, for example, for a price level of 100, I don't know what this is, 70 maybe, we have a price difference in absolute terms of €1. This is all in euro here. The model does not yield biased values, right? So we have negative as well as positive deviations. But here, at least in relative terms, for the smallest option price, we have the highest absolute deviation. So depending on the goal, depending on what you want to do, you might want to change from absolute deviations here to relative errors, but all this is again explained in the class. So this is about calibration, where we make use of efficient markets. But if you want to trade again, then the tide turns, the coin turns, and we get here from 4 on into the PyAlgo world. So still, we are here in the computational finance world, DX analytics. This is, again, the world where we might benefit, where we believe and where we trust in efficient markets. And you see, as the major package, I'm importing DX analytics. Here, I'm modeling the risk factors, the constant short rate, a geometric Brownian motion from Black-Scholes Merton, used since decades. I can visualize, select few of the simulated paths, then maybe a second risk factor here with a different volatility, so higher volatility than the valuation model. You recall there was this, it's maybe now worth going back to this one, risk factor 1, risk factor 2. Now we come up with the options themselves, right? So here a market environment for an American put option, present value, the delta, the gamma, vega, all numerical values. These are all numerical estimators, theta as well as rho. And we have here a second derivative based on a second risk factor. GBM2 is a European call option. Again, you see this behaves like Black-Scholes, simply calling the methods delta, gamma, vega, theta, rho. They can also be used a bunch of parameters. So risk factor 1, 2, European derivative and American derivative. Now, the next step here is to come up with an options portfolio. We model now certain quantity sets, I can say. First derivative position put, second derivative position call, and I now come up with, finally, that's the final step, with a portfolio, including all risk factors, correlations, the positions, and the valuation environment. And this gives me, in the end, the derivatives portfolio. This might look like a little bit of overhead compared to, let's say, Black-Scholes Merton. That is overhead for Black-Scholes Merton. You can be more efficient with DX analytics, but DX analytics is not a replacement to any analytical formula of Black-Scholes Merton. It is a package that allows you to do stuff that closed form solutions and other numerical methods don't allow you to do. Now we get the values and the statistics. So what is happening now here, again, have a look here. We have risk factors, we have the instruments, we have the positions, we have the portfolio. Now, when I initiate the valuation, it simulates the cash flows forward, and for the American option, for example, it comes up with the optimal exercise policy and risk neutral discounting backwards. Right now we have seen basically everything in action, although the relationship might not be fully clear at this stage, at least. So we then have risk reports with regard to deltas. What are risk reports? They allow you to do what if analysis. Right here we have the delta. So this is the 100% initial price. And here, what happens to the portfolio value when there is a 10% drop? So from 100% to 10%. Or what happens when the initial value increases by 10%, right? So this is what we see here. We can also have a net view on that, where we say 100%, this is the net portfolio value. And when, for example, the initial value of the first risk factor decreases by 10%, we have a drop in portfolio value by 15%. So typical what if then analysis here. The same here with regard to the volatilities. Same idea, a little bit more granular now in 5% steps. So meaning 5 percentage points relative to the volatility. So this is not 5 points, 50 to 45. This is here 5% from 50%. So need to be careful in this regard. Still in the world of where we try to benefit from the efficient markets and where we translate our theory into the application here with the package. Now we enter the world. Now we enter the world of the market prediction. Before we get into that, there's a question with regard to Bloomberg data. Frankly and honestly, no. I don't have access to Bloomberg. I have discussed with Bloomberg team members, product managers, etc. A couple of times. So it was even initiated by them, but they never came around the corner and said, well, we provide you with some teaching tool there that we could use for the program. So they are, as might be known in the market, they are not as open, for example, as Refinitiv. Refinitiv has like a pretty active, open developer community. They indeed have trial accounts and all of that. But I must say, confess, and even complain a little bit that Bloomberg never was willing nor open to provide us with kind of a teaching environment that we can use on an ongoing basis to provide people like you who are now asking about the Bloomberg integration. I'm not happy about that, so I'm not contractually bound to Refinitiv in his contacts, but I tried, but they didn't want to follow through in this regard. So now, in the algo trading world, we want to try to overcome the curse of the efficient markets, because we want to beat the markets. If we would fully believe and trust in efficient markets, random walks, etc., then we wouldn't even try to trade in the markets, right? If you trade, you basically want to outsmart, let's say, an ETF that you can invest in at a very low cost and simply hold it for years on end, let's say for retirement. So the game of algorithmic trading is to try to outsmart the market, to beat the markets relative to a benchmark. And this is here now where I introduce AI in finance, market prediction based on financial features. So I work with the data set here, a static one, which is hosted on my server. You see here 15,000 open, high, low, close elements. With Wanda, you get this data for free. It's open once you have opened a test account. And I come up here more or less arbitrarily with a bunch of financial indicators like high minus low, or volatility V1, V2, simple moving average 1, 2, momentum 1, 2, and a couple of others, right? So this is what I do here. So to have some indicators, you could also add here to the mix whatever comes to mind, like RSI, Bollinger Bands, you name it. This approach is pretty agnostic in this regard. So we have the features, we have the data, we split it here into 60% for training and validation accordingly, right? And then have the rest of it as test data. We work with 10 lags, apply Gaussian normalization, and here you see that's like data pre-processing. You will see this over and over again. In a little bit more simple way, I've shown this in the context of the first notebook, working with lags. Here we deal with different features, plus lags, plus some of them that get normalized and others not, but the approach is more or less the same. I do normalization and lagging, and I end up with a total of 210 features in this context, right? So when I have a brief look, so I cannot really display it all. You see here, they are like the triple dots. So this is now a data frame with 210 columns. So it doesn't even show them all, right? Therefore, it is commented out here in this context. So I now use a deep neural network from scikit-learn. So now we are really in the middle of AI. Deep neural network, 2 hidden layers, 256 hidden units each. I do the fitting. You see on this level, this is all pretty fast. And I do the vectorized backtesting, details later. And what we see here is the blue line, which is the passive benchmark investment, and the green line, which is the strategy which outperforms over the period of time, covered here the passive benchmark investment significantly. If you would add leverage for the mix, let's say 10, we would end up maybe with some 50%. But, and this is the biggest but you will hear today, this neglects transaction costs, for example. So this is what I would call, in particular in the context of AI and finance, a statistical inefficiency, but it might by no means be a economic inefficiency. So statistical inefficiency means that on a theoretical basis, on a numerical basis, I might be able to come up with such a strategy which outperforms the market considerably. But when I want to implement a trading strategy in order to benefit from my statistical inefficiency, I might discover kind of easily and quickly that the transaction costs would eat up any benefit in this context, right? So, but first things first, I need some statistical edge in order to gain an economic edge. That's the basic ruling here. So here we are in the game of trying to beat the markets. But if we want to implement a strategy to exploit inefficiencies that we might have discovered, I need a platform. So here I'm working with Wonder, with our package. So for example, the first 4 instruments. So when I get that one, you see there are a bunch of instruments that I can trade. So this differs from jurisdiction to jurisdiction. For example, Brent crude oil is something we have a look at, also Euro US dollar, and maybe some other indices. So Germany 30, which will be changed to Germany 40 sometime soon, and some other like SPX 500 or NASDAQ, Russell 2000, and a bunch of instruments, some 124 or whatever this list is. So usually I only show a couple of them. So with regard to Euro US dollar, here I'm retrieving historical data. And this is, again, because there have been a couple of questions with regard to data retrieval and then trial accounts. When you have a trial account with Wonder, you can get this historical data from Wonder for free. So there are no differences between the paper trading account and the real accounts. You see here I'm retrieving data for last week, just 1 day, 1 minute bars, mid price. I get some 1,320 data points for the 8th of January, midnight until 10 p.m. here in this context. So I backtest here a momentum strategy based on Wonder data, do a couple of statistics here, so whether this holds true or not. So my hit ratio is not the best in the world, it's just 48%. But let's have a look at it. So I have a slight outperformance. This was not the point here to come up with fantastic results, but I just adjusted it to the last available trading day, so that we have most recent data and this simple strategy. Same holds true what I said before. This might look nice, okay, whatever you want to call it, but there are no transaction costs whatsoever involved in the analysis here. Therefore, we need to be pretty careful with our judgments. But here you see visualized for the last 200 data points, 200 minutes in this context, how often the position changes from long to short. So now placing trades is the point. So let me open my Wonder web app. I should be still logged in. Yeah, here I am. So it's now loading data from my account. There's one open position. I wished I would have traded it with 10 times leverage. This trade alone would translate into plus 600%, but this is just a theoretical account here. But what I want to show you is that I can now create an order for Euro GBP. You see here the whole object that is delivered back. So create order Euro GBP units 100. Let me check. And to see indeed Euro GBP 100. So this is now opened. Just by executing a single short line of Python code, I have opened a position here in this account. This is a paper trading account, right? So I could close it here manually, but this is not what you typically would do. You would rather go and say, well, here I have placed or opened a long position of 100, and then, for example, you close it directly. Maybe you want to go short 100, but here I'm just closing the 100 by creating an order with minus 100 units. You see here that I get another object with all the details at what time, what the price was, and commission, P&L, and all that stuff there. When I check back with my account, you see my position, my FX position, FX position is now gone. So just by executing it, and there is activity and my most recent trade. So this is something I checked earlier today, right? And here you see now my two most recent trades, just like a minute or two ago executed. And not only that I can check this back on the web application here, I also see the last two trades just executed and the P&L for closing it. So I lost a little bit of money. Everything else would have been a surprise. And when you think back of my pyramid, I said, well, there comes the point when you need to place orders, where you need to work with streaming data. And here you see a little example. Maybe I do some 17, for example, and you can stream. Oh, Bitcoin has lost quite a bit during the day, some 3,000 roughly. You see BTC, US dollar. I cannot trade with my own account BTC, but the streaming works. I can also go with Euro, US dollar. Let's say there we usually don't have that many ticks and up there. Yeah, currently it's pretty active. Also going fast. It depends a bit on the time of the day. And we see now streaming real-time data for Euro, US dollar, right? So can again stream. We get the data. This is BCO now. For all the instruments that I've shown before, we can stream data. We can combine this then with our logic for predicting and with placing orders. I also have one more for Rwanda, but for the sake of time, I'm skipping over that. The final demo is about reinforcement learning. And again, just like a quick run through here is, you might recall it from the slide card poll. I said this is a nice intro environment. We talk in this context about the action space. Here I have only two actions. Then the observation space, that's kind of like the state of an environment. Here it is card position, card velocity, pole angle, pole angular velocity. Then I need to take actions in order to step an environment forward. So just that you have heard these expressions and notions. And when I execute this code now, it will visualize the environment and will open here this as well. So in order to see this again, let me maybe put the two of them together there. So otherwise I cannot have them at the same time open in the background. You see here the can get rid of that. I don't need this anymore. So when I execute this, you see both here in the Jupyter lab as well as on the right hand side the visualization of the environment. Card pole is about balancing the pole on the card, so by pushing it to the right and to the left. That's the basic idea, and the agent here should learn how to do this. So going through the code here, there's like a very basic introductory example with regard to one approach of solving this, not really about reinforcement learning. So once we have that, and now we see it at the end here, we can test the results. So you see here 200, and 200 is a perfect score. So here it's not the goal to balance the pole as long as possible. So once I survive, quote unquote, 200 steps of the environment, then I'm considered to be a successful agent. So of course, I'm not doing it here with the joystick or with the keyboard. The agent itself, the software, does it. And now, once I have trained such an agent, I have like a little bit more of an intelligent agent, not just a random one as before. You see how it balances the pole. This runs pretty quickly here, right? So I can repeat this. You see it reached 200, and down there on the lower right, you might see, it balances it, and once it reaches 200, this is now an agent which has mastered this little game. So it doesn't fail anymore with regard to balancing the pole. It always, I'm not sure about always, but it seems like it always, for our trials here, has reached so far the goal, and I can repeat this a couple of times, and I see it again was successful here. An agent is overall considered successful when over 100 consecutive games, the average score is 195 or above. All the details, more on this so fascinating field in the program and the respective classes. You have, of course, access to these resources. I've shared already the link. So you can play around with it as of now, or you simply say, well, lots of exciting stuff. I keep that for later. It comes a little bit later because it requires a couple of other skills in this context. So let me clear this up. So also this one here, I usually like to save my stuff without having that code executed. This should also be cleared up, and I'm finished with this little demo. Just to whet the appetite of what to expect and what to come in this context. Particularly with regard to trading here, we will need additional accounts, but they are free and easy to set up, so don't be afraid of that. You will be provided with the respective details. Quant platform, Python with Docker, efficient markets, model calibration, and DX analytics, where we make use of efficient markets, and then market prediction and wonder trading platform, reinforcement learning, where we try to overcome from an algo trader point of view the efficient market story in this context. There's also the link to the gist done there. So a study plan for the programs. There was a question how to best get started here. I have shared this. This is something that is updated at least once per week, sometimes twice when there are changes. And you see here, you should read this row by row. In the first 3 weeks, the two core programs are going hand in hand. You then see with finance with Python, obviously here, you then see the live sessions in red. Typically, I highlight them so that you don't miss the live sessions if you want to follow along. We have financial data science, tools and skills. And then what I mentioned before, we have AI in finance book on the Quant platform. So watch out for book. This is what is in any case recommended and optional. You also have AI in finance under a class which is simply called AI in Finance traditionally. You also have the other optional resources, so Python with Excel can be started from the outset. You don't need that much Python at the beginning. Later on, we have OOP or some reinforcement learning, what we discussed, starts also a little bit later. And so we go week by week, but in the beginning, finance with Python, what you should focus on, data types, structures, and tools and skills, or what. And then at least you should also have a brief look at AI in finance. If you say, well, I start that part a little bit later, this is also not harmful. But for example, predicting market movements here, this relies then heavily on what is covered here in AI in finance. Yeah, that's the basic idea. And as we go, you will see this red frame move down, 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 week by week. For the next week, I've already planned here sessions. This might be a little bit in flux, so don't take this for granted. There might also sometimes be short notice changes, but these days when I'm not traveling that much, there is not that much of a risk that I'm not there. But for example, just a personal story, since yesterday until around noon today, we had serious issues with our internet service provider here. So I was not even sure whether we could do a proper session today, but I'm grateful that they managed to fix the problem, which was not only related to our household here, to our building, so to say, but to like our whole city. So I didn't yeah. At first I didn't believe, but later on I was so happy that they resolved the issue just in time. So this is what I mean by maybe there is some short notice. Please really keep up with the invites that I send, and also when there is some changes, as fast as I can, I will update here the live session timings in this context. And yeah, this is how we go until we reach week 12. And from that on, we will have the practice and final project phase in this context. There's a question with regard to optional. So everything that is under this column here is meant to be optional, right? So Here in AI and Finance book, we have recordings, we have code, and we have reading assignments. So plus chapter 1 means chapter 1 of AI and Finance. AI and Finance 1 is the first video, the first session of AI and Finance book class. So this is not just related to the video part, this is related indeed here the whole thing to the first module and the first chapter in this context. Yeah, review questions, exercise, and test projects. Starting with week 2, you will have the opportunity to work with exercise, to come up with your own solutions, and maybe later on to work on a little bit more involved test projects. And every 3 weeks, so after week 3, 6, 9, and 12, we provide also a set of review questions. This is more like for you to test yourself with regard to the red line through the program, if you have like still the overview of all the topics. So here are the review questions for the first 3 weeks for the algorithmic trading program. There's another set for the computational finance program, so Python in general, finance with Python, tools and skills, financial data science, AI and finance. So this is for you to test. This is not like that you should hand in something here. You should say, well, when I ask here, like one of my favorite topics, what do people understand under the technological singularity? So if you have read carefully through the resources in AI and finance, then this should be an easy answer for you, easy question and easy answer for you to give in this context, right? So that's the idea of the review questions. Then we have simple to more involved, sometimes difficult exercises here, similar to what is covered in the materials themselves or in the book, in the text, in the code, and a few test projects, which might be a little bit beyond, outside of what exactly is covered, right? Here, a little bit of a fun test project, and sometimes it might be a little bit more involved, working with a different data set or whatnot. So you should work on the exercise and then have a look at the sample solutions. And we don't provide sample solutions for everything, and that's for good reason, right? So, and there won't be, don't ask me if there are no sample solutions, most probably there won't be any. So you need to get accustomed to the situation. This will be the same for the final project, for the practice phase, and in real life, right? That there is no sample solution. And in general, so you can relax, there's also not one solution only, right? Typically in programming in our field, there might be like 10 different approaches, which are perfectly valid to solve a given problem. And if you get stuck with whatever topic, issue, detail, you make use of the user forum, right? So I've shown you already or walked you through the basics of the user forum. You should read through it. You should digest what is there. You can also search for stuff. So I didn't show you the search functionality, but there is a search thing. So before you post maybe a question, maybe you search for related term or a central expression. Maybe something has been answered already, or your exact same answer has been provided already. And you should go through that. Again, email is not the right way in the program to go through it. And there's a number of reasons, because here you give on the user forum the chance to our complete team to answer it. If you write me an email and I'm not available, let's say for 48 hours, then you sit there and you are a little bit surprised that you don't get feedback, right? And again, the team gets notified by email anyways for every single post and every single reply. Please, 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 read through this post as carefully as required. So when you post something, do yourself and everybody else a favor and try to create a minimal, complete, and verifiable example. Use as little code as possible that still produces the problem. Provide all parts needed to reproduce the problem in the question itself. Test the code you're about to provide and make sure that it reproduces the problem. So why am I emphasizing that much? Because again, you will be surprised, annoyed even, when you post something and I ask you several questions. Often I will even just post the link to the Stack Overflow page. Because there are a bunch of forum posts, and I know, I mean, if I do it myself, for example, I'm interacting with our team and I say, well, man, I'm working on X, Y, that. Why doesn't it work? There is a big issue, help. And then they say, well, what are you working on? What is the context? What exactly did you do? Can you share the code? And therefore, I can completely relate to the situation, because when you are stuck with a problem, you're already getting nervous and wanna quit or whatever, right? And then you hastily put together something in this context, but just think first and foremost of the other side who receives your message, right? There's things like in the one session of AI in finance, I use exactly the same code, but the results are different. Please help. I mean, everybody can say that basically there is no chance for us to help in this context. Therefore, try to be as specific as possible. And I was following along the video of session number 3 in AI and Finance book. In the Jupyter notebook that is shown there from line 5 on, there is the following code, and then you post the code. And then you try to keep it as small, as minimal as possible, as complete as necessary, and you check whether it is verifiable. And then I'm pretty sure we are quick and professional to help you with any issue that might arise in this context. And last but not least, I said this is for me like a little bit of a tradition that I want to close with this part, importance of practice. And I have a couple of quotes from one of my favorite books about expertise and about high performance. It's from Anders Ericsson and his co-author, Peak Secrets from the New Science of Expertise. And it's, on the one hand, it's like a message to you personally, also as a group, but it's also a little bit of a, how should I say, a softener, and it helps us to relax in terms of like getting not to the point where we want to quit too early and where we like getting desperate because we might not at the first try understand everything that is covered or everything that is required, right? So let's get started here. When you look at how people are trained in the professional and business worlds, you find the tendency to focus on knowledge at the expense of skills. So to put it in my words, it's not enough to master the program to just read the books. So when people reach out and say, well, you're publishing all these books, why do you share all this? You make your program obsolete. And I said, no. Just by reading books, it's like, this is like saying I have here, now let me turn around. I don't know how many math books and AI books and etc. finance books I have on my shelf here behind me, right? This is like saying I have 5 books available. So now I'm, I don't know, master of science in mathematics. I'm a master of science in deep learning. You need the skills, you need the experience. And this is what our program is about. You need to build, you should build, and you're supposed to build skills, not accumulate knowledge. Therefore, here the next quote, I believe the best approach will be to develop skills-based training programs. Ours is not 100%, so we still build the theoretical foundation to some extent, and some practical notions, of course, are shared. But we want to follow the third quote here, training should focus on doing rather than on knowing. You should rather skip, let's say, the one or the other chapter of a book, but watch the videos, follow along the live sessions, go through the codes, and do the exercises. So rather skip the reading than the practical parts of the program. That's the message. And here as well, so no matter which area you study, music, dance, sports, competitive games, or anything else with objective measures of performance, you find that the top performers have devoted a tremendous amount of time to developing their ability. So there is no master that falls from the skies, as we say here in Germany, right? And if it's music, dance, sports, competitive games, or anything else, and then anything else you can now put in here, financial engineering, algo trading, Python programming, general technological skills, software engineering, etc. So this anything else is everything that we're going to cover here, right? There is no top performer which you see at the conference these days, probably digitally, who has done this for 4 weeks and now performs during a keynote a live coding session. This takes time. So, and this is like, I think, comforting that if you get started on your journey, simply honor the fact that it will take time. right? Don't get desperate or lose interest, right? You need to keep up. So, like Woody Allen said, showing up is 80% of success, right? So show up, do your stuff, repeat, 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 do, instead of like just think and read, right? So I think this is quite comforting for all of us. And last but not least, here from one of our, you see here, February 2018, and I still leave it here. I have a couple of other quotes that I could put in here, but this was like after building the program over years already and trying to add more and more skills to the mix, where we thought, well, this might help people, this might be missing still, and this is like the piece which hopefully makes it a little bit rounder and better for people to understand. Therefore, I keep still this quote from Elvis, February 2018, where he said, I liked watching your videos, but it's much more interesting and educational to actually build something on my own. And this is how we change the program to empower people to do it on your own, right? You can watch 20 lectures on YouTube about the grand unified theory in physics, like string theory or whatnot. If you don't sit down and study for your own, pen and paper, same holds true for mathematics and so many other things. Or think in terms of playing the piano. You can watch playing Lang Lang all day, but this probably won't make you a master. You can watch Magnus Carlsen playing chess like a god on earth. This helps to a little extent, but it won't make you a grandmaster, even after 10 years of following along Magnus Carlsen. You need to get to the point where you say, well, fantastic, I did it on my own. I built the car on my own, right? I didn't go there, rented the car and brought it back a day later. I can build it on my own. Yeah, this brings me to the end. Maybe there's a final question that I can answer in this context. All the live sessions are still available. So for example, there have been mentoring sessions in the last cohort. We will have our own mentoring sessions, but they are still available and you have access to all the resources that I promised you. So I change sometimes a little bit the numbers. I'm not the biggest believer in like saying, well, we have 300 hours of recorded instruction instead of 200. So we rather try to improve the 200 that we offer by default, but there are still many, many more resources that you have access to in this context. It's a good question. And having said that, with my plenary about the importance of practice, I now send you into the program, into the first week. Wish you all the best. Wish you a great start. First and foremost, happy Python coding. This is our credo. And successful algo trading in the end, as well as a fantastic financial engineering time. I hope you will be or are as excited as I am. And I see you for sure in the next sessions. There are many, many more to come. If you have questions, reach out via the user forum. All the best. See you in one of the next sessions. Take care. Bye-bye.